What causes the Earth's magnetic field? Our planet's magnetic field is believed to be generated deep down in the Earth's core. Nobody has ever taken the mythical journey to the center of the Earth, but by studying the way shockwaves from earthquakes travel through the planet, physicists have been able to work out its likely structure. Right at the heart of the Earth is a solid inner core, 2/3 of the size of the Moon and composed primarily of iron. At a hellish 5,700 degrees Celsius, this iron is as hot as the Sun's surface, but the crushing pressure caused by gravity prevents it from becoming liquid. Surrounding this is the outer core, a 2,000-kilometer thick layer of iron, nickel, and small quantities of other metals. Lower pressure than the inner core means the metal here is fluid. Differences in temperature, pressure and composition within the outer core cause convection currents in the molten metal as cool, dense matter sinks whilst warm, less dense matter rises. The Coriolis force, resulting from the Earth's spin, also causes swirling whirlpools. This flow of liquid iron generates electric currents, which in turn produce magnetic fields. Charged metals passing through these fields go on to create electric currents of their own, and so the cycle continues. This self-sustaining loop is known as the geodynamo. The spiraling caused by the Coriolis force means that separate magnetic fields created are roughly aligned in the same direction, their combined effect adding up to produce one vast magnetic field engulfing the planet. What is Earth's magnetic field? You can see it, but there's an invisible force field around the Earth. Okay, not a force field, exactly, but a gigantic magnetic field surrounding the Earth, and it acts like a force field, protecting the planet and all the life from space radiation. Let us take a look at the Earth's magnetic field. The Earth is like a great big magnet. The North Pole of the magnet is near the top of the planet, near the geographic North Pole, and the South Pole is near the geographic South Pole. Magnetic field lines extend from these poles for tens of thousands of kilometers into space. This is the Earth's magnetosphere. The geographic poles and the magnetic poles are far enough apart that scientists distinguish them differently. If you could draw a line between the magnetic north and south poles, you would get a magnetic axis that's tilted 11.3 degrees away from the Earth's axis of rotation. And these magnetic poles are known to move around the surface, wandering as much as 15 kilometers every year. Scientists think that the Earth's magnetic field is generated by electrical currents flowing in the liquid outer core deep inside the Earth. Although it's liquid metal, it moves around through a process called convection. And the movements of metal in the core sets up the currents and magnetic field. As I mentioned at the top of this article, the magnetic field of the Earth protects the planet from space radiation. The biggest culprit is the Sun's solar wind. These are highly charged particles blasted out from the Sun like a steady wind. The Earth's magnetosphere channels the solar wind around the planet so that it doesn't impact us. Without the magnetic field, the solar wind would strip away our atmosphere. This is what probably happened to Mars. The Sun also releases enormous amounts of energy and material in coronal mass ejections. These CMEs send a hail of radioactive particles into space. Once again, the Earth's magnetic field protects us, channeling the particles away from the planet, and sparing us from getting irradiated. The Earth's magnetic field reverses itself every 250,000 years or so. The North Magnetic Pole becomes the South Pole, and vice versa. Scientists have no clear theory about why the reversals happen. One interesting note is that we're long overdue for a reversal. The last one happened about 780,000 years ago.